So we are going to do the depth first traversal recursively. And for all of you, those who don't understand what recursion is whereby a method calls itself. I mean, we remember we called the depth first traversal method that we just created iteratively, and then we called it in the main method. But in recursion, uh, the depth first traversal is supposed to call itself. I mean, you'll understand as we move if you don't. So, another thing we should remember is that maybe we should just scribble something. The recursion uses all stacks, which is what we've been using, the stack. So the first method will be executed, and then second method follows and follows and follows. And you remember about the cycles now. A recursion also is supposed to have some cycles too, because if there is no condition to terminate the method, then it will call itself forever. Like let's say if you had a method that maybe adds two numbers, let's just do something. It will return an integer to add numbers. Then it will take two numbers, int 1, int 0, and int t. So if maybe we will say return add number, the first one maybe to be 0 plus t. When you guys don't understand if I use a method that is not clear. So I believe without wasting more time, maybe we should just dive in and see. So it will be a private static. It will also be void because you're going to print out things on the console. So it will be a recursive depth first. Recursive depth first. As usual, we're going to take in the graph and the start node. And the start node, so in a minute, so and the start node. So first things first. You remember, since now we are going to do it recursively, our stack will be the method itself because it's recursive. So in our stack, what do we do first? We consider a neighbors, right? We consider the neighbors and then we add them into the stack and then we print them out for us to see them. So we're just going to print out the start node. And then now we're going to loop through the neighbors. And then instead of adding them into the stack, what we do, we add them into we call the method itself, providing the graph. And then the neighbor, maybe we should have just initialized the neighbor here. So node neighbor is equals to stats.get neighbors. We get the current neighbor. Get the current neighbor. So here we're just going to pass in the neighbor. So maybe we can give it a try and then we debug it to see what happens. So recursive depth first. And then as usual, you're going to provide the graph and the start node. So we're just going to comment out this. We put a breakpoint. We want to see the iterations at the stacks, the call stacks in our iterations. So what do we do? Let's run it in debug mode. Then maybe as it runs, let's just say your graph. We didn't set that file. God damn it. Oh, we have it. We have it. So, this is our stack. The method, the recursive method is our stack. So we are so in our first iteration, let's just do this, and this is the graph in the start node. So in our first iteration, we are at node A. So what do? We just enlarge this, minimize this. Yeah, something of the sort. That way. So in our first in our first call, let's just walk through it. So we are getting the name which is there. And then we look through the neighbors. We have two neighbors. Remember, yeah, at node A we have two neighbors, which the first one, let's just see the first neighbor. As you can see, the first neighbor is we didn't get the name, but we can say it from here. The first neighbor we are at B here. So we continue. Then we call the method again. Now we are in our second recursive method. Now as you can see, we are at node. Let's just see what happens. We are at node. Maybe this is the information that I need. We are at node B right now. We get the neighbors. You can see its size is 1. And the neighbor is node B. So the neighbor is node B. So we continue traversing. And then we print out. Remember, we've provided now the neighbor then to the recursive method, which is D. The neighbor was D. So in our recursive method, we print out the node, which now the start is D, and then its neighbors, it also has one neighbor, which is F, as you can see from the diagram. Node F neighbors node B. When we step over again to the code, now we are getting the neighbors, which is node F, and then we use it as the parameter. Now you can see now our start node is node F. Now if we step through again through the code, when we get F neighbors, F doesn't have any neighbors. So we're not going to call the recursive method again. So it skips over to the end of the code. So our condition is if the node doesn't have neighbors, then it means that the method will call itself. Let's just see what happens. Since now we are at node, the start node is D. So I just went back. So let the last one is so not B. Then where am I at? C. I believe you understand what we've just done. So what now we're going to do, we're just going to see the output of our code. So I'll stop the debugging and then run it to see how we've traversed through. I mean, we've gone from A, then to B, then to D, and then to F, and then from F we went to C, and then to E. Remember in our recursive method, we also add C, but since now the method uses a stack inside, so it had to pull out the last neighbor to be added, which was